Hello, grade sevens. We're already on the last section of this unit, so section 11.4, and we're going to be solving two-step equations. So the type of two-step equation we're solving is y equals ax plus b. So two steps, meaning that there's going to be some multiplication happening, a times x, some number multiplied by x, and we're going to be adding or subtracting a number to that as well. So the last couple lessons, we've been looking at solving questions involving addition and subtraction. Then we looked at the question involving multiplication and division. And now we're just looking at combining some of those. So first we're going to do the show you knows, which were in the textbook. And we're going to do it by modeling the situation. So just looking at this, going back to that teeter-totter example. So if we have 3w plus 3 is equal to 6. We could model that. Let's draw our teeter-totter here. So you have a teeter-totter. The equal sign means that both sides of our equation are equal, which means that both sides of our teeter-totter would be the same height. They'd be balanced. And on one side, we have our three w's. W, W, and W. And we also have on that side 3. So 3 counters. We can use red. 1, 2, 3. On the other side of the equal sign, so the other side of the teeter-totter, we just have 6. So we'll have 6 counters. 1, 2, 3, 4, 5, 6. Now these two sides are equal to each other. What we want to figure out is how much is 1w equal to? How many counters is 1w equal to? Now to solve that, we want to get just 1w on one side of our teeter-totter, and then how many counters would balance it out on the other side. So if we had an actual teeter-totter, an actual scale, sort of like this to balance out, well, we want to eventually just take away everything from the left side, so there's just 1w, making sure that's going to be equal to the same amount on the right side. So the first thing that we would do on the left side is take away those 3 counters. Now if we were to do just that, suddenly this left side would be lighter. So to make it still balanced, we also have to take away 3 counters from the right side. And now we see that the 3 w's are equal to our 3 counters. So if we want to find just what 1w is equal to, we would divide that by 3 to get just 1w. There's 1w left. And when we divide the right side by 3, we get just 1 counter left. And we get this situation where 1w is equal to 1 counter. And we can check and see if that makes sense. Does it make sense that 3 times by 1 plus 3 is equal to 6? Yeah, that makes sense, because 3 times 1 is 3 plus 3. That equals 6. So 6 equals 6. There we go. And we're able to solve it. Okay, let's do the second one. So in the second situation, we have 2p plus 4 counters on one side. I'll just draw the counters quickly. So there's 4 counters on that side. There's 10 counters on this side. And there are 2p, 2 unknowns, 2 variables on this left side as well. So there's p and p, 2 of them. Okay, so we want to figure out how much would 1p, that one unknown, be equal to. So to keep things balanced, I want to get just 1p on one side. I take away the 4 counters on that side. I also take away 4 counters on this side. Did I take away 4? There we go. I took away 4. Okay. And so now I have that 2p is equal to 6 counters. Well, I want to know what 1p is equal to, which is half. So if I take away half of the weight on this side, on the left side, I also need to take away half of the weight on the right side to keep things balanced. And now at the end, I see that p is equal to 3. So that's what I took things away in equal amounts on both sides. I end up with p is equal to 3. We can check that. So we had 2p plus 4 equals 10. I'm saying that 1p is equal to 3. So if p is equal to 3, then 2 times by 3 plus 4 equals 10. 2 times 3 is 6. Plus 4 is equal to 10. Well, 6 plus 4 is 10, and 10 is equal to 10. Therefore, 3 must be the solution to what p is equal to. Okay? So that's a way how we can model it with our teeter-totter diagrams. Now that's one way to do it. There is now the more basic way is by, as you see in this question, applying the reverse order of operations. Reverse order of operations. If you think back to our teeter-totters, the first thing we did when solving, when we had our 2p, let's draw this out again, and we had our 4 counters and our 10 counters. The first thing we did was we got rid of this 4. We got rid of this positive 4 here. So we worried about the addition first, and then after we figured out the addition, we figured out the multiplication. So that's the reverse of the order of operations. In order of operations, you do multiplication and division first. But when you're solving, now that's for if you, have a problem without a variable. But when you're trying to solve for a variable, you're actually having to sort of undo the equation. You're having to do the opposite. Okay? It's sort of like, when you get changed in the morning, you put your clothes on in a certain order, and when you get unchanged, you have to take them off generally in reverse order. You can't, you don't often take off your shirt and then your jacket. Usually you take off your jacket and then your shirt. But when you're putting them on, you put on your shirt, then your jacket. So since we're trying to solve for this variable in here, it's like we're having to undo and take off the clothes of this equation. And so we have to do it in reverse order of operations. Okay? So let's see what that looks like without using any modeling of a teeter-totter. So if we have 5n plus 7 is equal to 32, what we're going to do is we're going to undo the addition or subtraction first. So I want to get n all by itself. N is being multiplied by 5. It is also having 7 added to it. First, I'm going to get rid of the addition and subtraction. So I subtract 7, and I subtract 7. Okay? Now this plus 7 minus 7 equals 0, so those cancel out. Now I rewrite my equation. It's always a good thing to just rewrite. So on the left side, I have 5n, and on the right side, I have 32 minus 7, which is equal to 25. Okay? Now I'm going to show the next step. So now n is being multiplied by 5. I want to get rid of that 5, so I have just n on the left side. To do the opposite of multiplying is to divide. And I divide by 5 on the right side, or on the left side, and I divide by 5 on the left side. Keep things balanced. The 5 divided by 5 is equal to 1. So those balance out, or cancel out, because we're left with just one n. And now I can rewrite, and I'm finally left with n is equal to, because all I'm left with on the left side is n. On the right side, 25 divided by 5 is 5. And so there's my solution for what n would be equal to. Okay? We can now check our work. So check. I will substitute my solution back into the equation. That's how we check. So I get 5 times by 5, because 5n means 5 times by n. I'm saying that n is equal to 5. 5 times 5 plus 7 is equal to 32. 5 times 5 is 25. So now I'm following normal order of operations, right? Since I'm not solving for a variable in my check, I'm going to do the multiplication first and then the addition. So 25 plus 7 is equal to 32. And 25 plus 7 is 32. So 32 is equal to 32. My left side and my right side are balanced, are equal when n is equal to 5. And therefore my solution that n equals 5 is correct. Okay, so here in our check, I use the normal order of operations, doing multiplication first, because we're not solving for a variable. We're not trying to undo the equation to find something in it. I'm just solving the multiplication and addition. So we follow normal order of operations. But when we're solving, I do reverse order of operations. When I'm trying to find a variable, I first have to get rid of the addition or subtraction, and then I do the multiplication or division. Okay, let's do this next example. Oh, okay. So 53 is equal to 4r minus 11. Okay. Here, I am first going to, I'm trying to find what r is. So I first need to undo the things that are being done around it. So I'm going to add 11 to both sides. I do that by writing it underneath. I just find that that's the simplest place to do it, the best place to do it. I'm also going to add 11 to this side. Since we had minus 11 and now we're plusing 11, they cancel out on my right side. And now I can rewrite 53 plus 11 is 64. So I have 64 on the left side. And on the right side, I have just 4r. Okay, so here's what I have for my solutions, or my equation so far. Now I'm going to get r by itself. It's being multiplied by 4. So I'm going to divide by 4 on the right side. I'm going to divide by 4 on the left side. The 4's cancel out because 4 divided by 4 is 1. So on the right side, I'm just left with what r is equal to. And on the left side, I have 64 divided by 4. You might be thinking, what's that? When I'm dividing by 4, it's the same as dividing by 2 twice. So I could do 64 divided by 2 is 32. Divide that by 2 again. I know that is 16. And so the answer here is 16 is equal to r. That is the solution for what r is equal to. Okay? So there's those two steps. When you're showing your work, even if many of you can do this in your head right now, follow the steps. So first undo the addition, right? So I first did that step here. I first undid the subtraction, and then I rewrote, and then on the second line, I undid the multiplication. So don't fall into the trap. Sometimes it's easy to want to do it all on the same line and just like divide by 4 here and divide by 4 here. That just gets messy, and you're going to make mistakes, especially as you go further in math and have more complicated ones. So just do it one step at a time and rewrite. That's the best way to do it. We should check our answer here. So if I was going to check my answer, my equation was 53 is equal to 4r minus 11. And I said r was equal to 16, so let's see if that makes sense. So I put 16 in for r, so 4 times by 16 minus 11. So now I'm following normal order of operations because I'm not solving for a variable. So 4 times 16, well, that is 64. So 4 times 16 is 64. I'm subtracting 11. On my right side of my equation, I have 53. On the left side, I have 53. So I have 53 equals to 64 minus 11 is 53. Therefore, when I put 16 in for r, my left side and my right side are balanced out. So that is the right solution for what r is equal to. Okay, let's go through some word problems together here, and then you can get to work doing this by yourself. So a clothing store is having a sale. Jake pays $19 for 2 shirts and a pair of sunglasses. How much does Jake pay for each t-shirt? Okay, so he pays $19 total. Let's write this out. He has 2 shirts two tees, two t-shirts, plus, well, I'm going to draw my T differently. Tees plus a pair of sunglasses, and in total, he pays $19. So the question is, how much does he pay for each t-shirt? Well, we're told here in this picture that the sunglasses are worth $5. So our equation could actually be written as 2t plus 5 is equal to 19. And now, since we only have one variable, we can solve for what it is. So I'm going to do a reverse order of operations. So I'm first going to subtract 5 from the left, subtract 5 from the right. Always do the same things on both sides to keep it balanced. Plus 5 minus 5 equals 0. Oops. I rewrite, so I just have 2t left on my left side of my equation. On the right side of my equation, 19 minus 5 is 14. Now I want to divide by 2 on both sides. T is being multiplied by 2, so I divide by 2. I do the opposite operation, and I divide by 2 on the right as well. Did the same thing on both sides, keep it balanced. The 2's cancel out, because 2 divided by 2 is 1. So I'm just left with t on the left side, and on the right side, 14 divided by 2 is 7. So I said each t-shirt is worth $7. Does that make sense? If this is $7, this is $7, and we have the $5, 7 plus 7 plus 5 is 19. So that is the right answer for how much each t-shirt costs. Okay? So there's a situation that we could turn into a formula and then use to solve. We can do one more. Maury saw this sign advertising t-shirts and socks. He pays $30 for 2 t-shirts and 4 pairs of socks. So let's write that. So he pays $30 for 2 t-shirts and 4 pairs of socks. We can write that into an equation. So $30 was equal to 2 t-shirts plus 4 socks. Okay, 2 t-shirts plus the 4 socks. What is the price of 1 t-shirt? Okay, well, in this equation right now, I have 2 variables. If you have 2 variables, you cannot solve. But here on our the sign advertising this sale, it says get socks for $2 for each pair. Okay, so a pair of socks, 1S, is $2. So we can fill that in quickly. So we have $30 is equal to 2 times by the price of a t-shirt plus 4 times 2. Okay, that's 8. So this equation is actually $30 is 2 times by the price of a t-shirt plus the $8. Okay, now we only have one variable. We can solve this. We need to do opposite order of operations. 2t is having $8 added to it. I'm going to subtract the $8. So those cancel out. I'm going to subtract $8 here. Okay, 30 minus 8 leaves me with $22. So $22 is what he paid for 2 t-shirts. If I want to find the price of 1 t-shirt, that would be half the price of 2 t-shirts, or divide by 2. Divide by 2 on both sides. The 2's cancel out to give me the price of what 1 t-shirt is equal to, and $11 is equal to 1 t. Okay, my variable t, which stands for a t-shirt. So $11 is the t-shirt. Does this make sense? We can substitute that back in to our equation. So we have 30 is equal to 2 times t. We're saying t is 11, so 2 times 11 plus 4 times 2 it was. 4 times $2 per sock. We follow order of operations, so we do multiplication first. 2 times 11 is 22. 4 times 2 is 8. So we have 30 is equal to 22. I now do the addition, plus 8. 30 is equal to 30. Yay! Left side is balanced with the right side, so that's the right equation. Okay, one quick last one. The formula R equals 9t minus 70 models the chirping rate of a cricket at various temperatures. Apparently, crickets chirp at different rates, so different speeds, depending on the temperature. That is interesting. The variable r represents the number of chirps per minute, so that represents the rate. And t represents the temperature. So we have r is the rate, and t is the temperature. So when the rate is 20 chirps per minute, what is the approximate temperature? This is telling us that this equation, when we look at it, says that 9 times by what the temperature is, minus 70 gives you the approximate rate of a cricket's chirping. I don't know if this is an accurate equation or not. Maybe it is. But we're told, so we have this equation, r is equal to 9t minus 70. And we are told when the rate is 20 chirps per minute. So we have two variables in here, so we can't solve this right now. But here in the question, it tells us one of the variables. The rate is 20, so we can actually get rid of that r, replace it with 20. Okay, and now we have an equation we can solve because there's only one variable. So I can add 70 on both sides because I'm trying to get t all by itself. I first need to get rid of the addition or subtraction. So I'm going to add 70. I'll add 70. Okay, the minus 70 plus 70 cancels out. That's just 0. On my left side here, 20 plus 70 is 90. So 90 is equal to 9 times by the temperature. I want to get that t all by itself, so I'm going to do the opposite of what's being done to it to cancel out the 9. So 9t divided by 9, divide by 9 on both sides to keep my equation balanced. The 9's cancel out. 90 divided by 9 is 10. So we're saying the temperature is about 10 degrees when a cricket is chirping 20 chirps per minute. Okay, and there you have it. We can check, throw it back into our equation. 9t, so 9 times by the temperature. So if the temperature is 10 degrees minus 70, we're saying that that should equal 90. Or sorry, we're saying that that should equal 20 chirps per minute. 9 times 10 is 90, minus 70 equals 20. 90 minus 70 is 20, which equals 20. Okay, and there we've checked our answer. We've gotten it right. Okay, so just to understand why we're doing this check at the end, because I know to some of you, you're like, why are we doing this? Imagine if we made a mistake here and we got, we just added wrong and we got that, 90 divided by 9 is 9 for whatever reason. So we get 90 divided by 9 is 9. Now when we check our answer and we put that 9 back in for t, we get 20 is equal to 9t minus 70. 20 is equal to 9 times 9 minus 70. 20 is equal to, 9 times 9 is 81 minus 70. So 20 would be equal to, 81 minus 70 is 11. Is 20 equal to 11? No, that isn't right. So when you get the wrong answer for what the variable is equal to, when you do your check, it won't balance out. The left and the right side will not be equal to each other. So that's why we do that check, as strange as it seems, or as pointless as it seems sometimes. You do that just to know that your answer was right. Again, the answer was not 9, but 90 divided by 9 is 10. Okay? So there you have it. That's solving two-step equations. We're just doing equations that are involving multiplication. Next year you will be doing ones with division as well, although I'm sure many of you would know how to do that. So maybe we'll see some challenge questions about that as well. Okay, so check Google Classroom for what the assignment is. Make sure you ask and contact us if you have any questions. I will see you later, grade 7s.